Okay, let's jump right into it. So this is the Edexcel GCSE Higher Maths paper 2. So I've typed up all the questions. I thought we could run through all the questions. So without wasting any time, let's jump right into it. The first question says express 250 as a product of its prime factors. So if I get 250, two numbers at times to give me 250, 25 and 10. Are they both prime numbers? Nope. So the tree will continue. Two numbers at times to give me 25 is 5 and 5. They're both prime numbers, so let's just circle them. Two numbers at times to give me 10 is 2 and 5. And again, they're both prime numbers, so I can just circle them. So therefore, 250 as a product of its prime factors. I've got 2 times, there's 5 times 5 times 5. I can just write that as 5 cubed. Okay, so that's the first one. We've then got find the lowest common multiple of 30 and 25. So there's 2 methods to do this. I'm just going to use the prime factor tree method. Two numbers at times to give me 30 is 6 and 5. 5 is a prime number. Two numbers at times to give me 6 is 2 and 3. Okay, let's do the same for 25. Two numbers at times to give me 25 is 5 times 5, and they're both prime numbers. So all we need to do now is make a Venn diagram for both 30 and 25. What numbers appear in both of them? Well, 5 does, so I can put that in the middle. Are there any more numbers that appear in both? Nope, so let's put all the remaining in. We've got 2 and 3 on this side. And for 25, we've got just the 5. Now to find the lowest common multiple, all we do is we times these 4 numbers together. So 2 times 3 times 5 times 5. And that just gives me 150, which is the lowest common multiple. So that was question 1, and nice and simple, good way to start into the paper. Let's move over to question 2. We've got a ratio question. It says Sid, Tam, and Musa share £6,900 in this ratio. I can just say Sid, Tam, and Musa, 2, 3, 5. So just working out the total number of parts, we've got 2 plus 3 plus 5. That gives me 10 parts in total. Now we need to work out how much money each person gets. So if I know there's 10 parts and in total there's £6,900, I can write that as 10 parts is £6,900. So to be able to work out each share that they get, let's work out one part and then it'll be a lot easier. So how do I get from 10 to 1? Well, I divide by 10. So I'm going to do £6,900 divided by 10, which is just £690. So we've worked out one part. Now we can just work out for each person how much they're getting. So for Sid, he's got 2 parts. So I'm going to do 2 times £690, which we've got for the first part. So we get £1,380 for that. For Tam, how many parts has he got? He's got 3 parts. So 3 times 690, which is 1 part, is £2,070. And then finally for Musa, he's got 5 parts. So 5 times £690 is £3,450. So, yep, there are 3 answers. We've just worked out how much money each person gets, and that was for 3 marks. Okay, moving on. Here is a plan of part of Maxon's garden. There's a circle inside a triangle, which you can see here. There's a circle, and then it's inside a triangle. The circle has a diameter of 7 meters, which we can see here. So if it's the diameter is 7 meters, we know the radius is 7 divided by 2. So I'll just put that down. Maxon will cover the shaded area with gravel. So we can see the shaded area is just on the outside. So to work out the shaded area, we can find the full area of the full triangle, and then we can minus the circle from it. So I'm just going to write that down here. Area of triangle minus area of circle. So that's how you'd work out the area of the shaded region. It says gravels is sold in bags, and each bag of gravel will cover an area of 12.5 meters squared. So I'm just going to write 1 bag is 12.5 meters squared. It's really good practice to write down information out of the question to make the question a lot easier for yourself. Work out the number of bags of gravel Maxon will need. Well, we need to work out, well, what area is actually shaded to figure out how much bags he needs. And we know to work out the shaded area, we're going to work out the area of the triangle minus the area of the circle. So let's work out the area of the triangle. Well, with the triangle, we could split it down in the middle. We've got two right angle triangles if we do that. So you can see the right angle triangle there and the right angle triangle there. So just keep that in mind. If we had two right angle triangles, we're halving this 16. So we get 8 times the height, which is 14, and we times that by half. So just area of that triangle we've just found. We've done 8 times 14 times a half, so area of a right angle triangle. But because we've got two of them, so we've got one on this side, one on this side, we're going to times our answer by 2. So putting that in the calculator, we get 112 meters squared. Now let's work out area of the circle. How do we work out area of the circle? It's just pi r squared. So it's probably worth just writing that down for the examiner that you understand how to get that. So pi r squared, so pi times, well, we've worked out r, we know the diameter 7, so half of the diameter is the radius, so half of 7, let me just get rid of that. So 7 divided by 2 squared. Putting that in the calculator, we get 49 over 4 pi meters squared. So I'm just going to leave it in terms of pi because I want my answer to be as accurate as possible and I don't end up getting rounding errors early. Okay, so we've said to work out the area of the shaded region. Notice as well how I'm making it like my working out really chronological so the examiner can clearly see where to get the marks as well, and give the marks, sorry. So area of the shaded region, we've just said it's the area of the triangle minus the area of the circle. So the triangle is 112 minus 49 over 4 pi, and that gives us 73.5155. So I'll keep a few decimals after so we don't end up getting any rounding errors. So we don't actually want to work out the area of the shaded region. We want to work out how many bags does Maxon need. So because this is the area we're covering, and we know one bag is 12.5 meters squared that it covers, we can just do 73.5155 divided by 12.5 meters squared to figure out how many bags we need. And the answer to that gives us 5.8812. But we can't have 0.8 of a bag, so we're going to round it up because we need to cover that 0.8 as well. So we're going to need 6 bags. And that's how you do question 3. And that was for 4 marks. So that was a pretty good question. So there's a part B as well. It says Maxon finds that each bag of gravel only covers an area of 11 meters squared. So how's this different to the first one? In the first one, each bag covered 12.5, but now it's 11. How does this affect your answer to part A? Well, let's see what happens. If we do 73.5155, which is the area of the shaded region, and we divide that not by 12.5 this time, but by 11, the answer we get is 6.68. And if we look at that compared to our last answer, we now need 1 extra bag. We have to round that up because we can't have 0.6 of a bag, so it means we need 7 bags. So then how does this affect your answer to part A? We need 1 extra bag. Which makes sense. If each bag of gravel now is covering less, then you're going to need more bags to be able to cover more of the shaded region. And we've just shown that. So that's question 3 there. Let's move over to question 4. It says point C is shown on a centimeter grid. So by centimeter grid, what they mean is that each one of these blocks, that's 1 centimeter. That's 1 centimeter. So it's 1 centimeters squared, basically. So that's what it means by centimeter grid. It says point P is at least 2 centimeters from point C. So here's point C. It's saying point P is at least 2 centimeters away. So say, for example, this is 2 centimeters away here, because it's 2 blocks. It's saying at least, so technically P could be here, but it could also be anywhere else out of that circle as well, because it's saying at least 2 centimeters away from point C. Nadia is asked to shade the region where point P could be, so she shaded inside the circle. Her answer shown on the grid. Explain the mistake Nadia has made. So she should have shaded the outside of the circle because P lies outside the circle, which we've just demonstrated before. Say, for example, if C was, it says at least 2 centimeters away. So if P was here, which is bang on 2 centimeters, it could be further than that because it says at least 2 centimeters, not the maximum of it being 2 centimeters. That's a nice little 1 marker. Question 5. This year, the total weight of potatoes grown on a farm is 1/5 than last year. Okay, so 1/5 less. This year, the total weight of potatoes grown is 8,000 tons. Work out the total weight of the potatoes grown last year. Okay, so it's saying this year the total weight of potatoes grown on a farm is 1/5 less. Now, 1/5 as a decimal, if we convert that, is 0.2. And if we've got less, our multiplier is basically 1 minus 0.2, so 0.8. So if we do 0.8 times the number of potatoes, which we don't know, so x, because we don't know the total potatoes grown last year. So this potatoes grown last year, I've called this x. So what I've basically just said here, 0.8 times the number of potatoes grown last year, because it's 1/5 less, i.e. 20% less, is going to equal 8,000 tons. So this is what we need to solve to be able to find out the total weight. To get x by itself, I'm going to divide by 0.8. So 8,000 divided by 0.8, just to get rid of that. Putting that in the calculator, we get 10,000 tons, which makes sense. Always make sure your answer makes sense. If I've got the total weight of potatoes grown last year to be 10,000, and then this year it's gone 1/5 less, so 20% less, it's then become 8,000 tons. So my answer does make sense. If I ended up getting a number less here, then I know I've gone wrong somewhere. Well, that was a nice little multiplier question. Moving on, there's a reverse mean question. Here are 2 lists of numbers. We've got list A, we've got list B. As you can see, we've got 1 unknown in list B. We've got that x there. It says the mean of list A as a ratio to the mean of list B is 3 to 5. Work out the value of x. So what we can do is first, we can work out the mean of each list first. So the mean of list A, all we're doing is adding all the numbers up together, 276, add 400, add 157, add 139. We divide that by how many there are, and there's 1, 2, 3, 4. And the answer we get is 243. Let's work out the mean of list B. We're doing 530, add 500, add 270, add x, so an unknown, add 440, add 320, and we're dividing that by, we've got, don't have 4 this time, we've got 1, 2, 3, 4, 5, 6. We've got 6 this time. Now we can't really solve that because we've got an unknown x there, but we can simplify it. So I can simplify it down to, adding all these numbers up together, I get 2,060. We've got the x, and that's divided by 6. So I've got the mean of list A and I've got the mean of list B. So now if I put that as a ratio, so I'm going to just write mean of A to mean of B, I can put, I know it's 3 to 5 here from the question. And I've also worked out the mean of A is 243. And I've worked out the mean of B is 2,060 plus x over 6. So what I could do is, I just need to figure out how am I going to make a proportion of this to that way. Then I know whatever I'm going to do on the left-hand side, I'm going to do on the right-hand side. So I know 3 parts is 243 because I can see that there. I've compared it in that side. So then I could work out 1 part, and to get from 3 parts to 1 part, I'm going to divide by 3. So I'm going to divide this side by 3 and I get 81. Now, I don't want 1 part. I want to know what's the value of 5 parts. If I work out the value of 5 parts in comparison to this, I can make it equal to this and then solve for x. So I'm working out for 5 parts. So I'm going to times by 5. So therefore, I'm going to do 81 times 5. And that gives me 405. So I know 2,060 plus x over 6 equals 405, which is what should be here. So I just need to solve this to find x. Let's times by 6 first. 405 times 6 gives me 2,430. And then to get x by itself, I just need to minus that 260. So x equals 2,430 minus 2,060. I get 370. And that's my answer. So that's a good 5-mark question. To be fair, if you had time in the exam as well, if you made this here 370 and you added them all up and divided by 6, you could even find the mean as well and compare it to your ratio just to double check it is right, but you don't necessarily have to do that. But that seems like a sensible answer amongst them numbers. Okay, that's question 6. Moving over to question 7, we've got a right angled triangle. They've given us a length on top and we've got an unknown angle and we've got a length on the right hand side. Calculate the value of x. This is a SOHCAHTOA question. Remember, with right angled triangles, it could either be SOHCAHTOA or Pythagoras, but Pythagoras does not involve angles, so that's the reason why I know it's SOHCAHTOA. It can't be sine rule and cosine rule because we use them for non-right angled triangles. So let's label the triangle. So I always label the hypotenuse first, which is opposite the right angle. Here's our angle in question. So next to, adjacent to that is the 4. And then opposite that angle is 7. Which two lengths do we have? Well, we've got O and we've got A, so we're going to be using tan. So tan of the angle, which we don't know, is x, equals opposite, which is 7, over the adjacent, which is 4. So to find x, I just need to do tan to the minus 1 of that fraction, and it gives me 60.255. The question wants it correct to 1 decimal place. That 5 rounds a 2 up to 3. So it's just 60.3 degrees. Nice and simple 2-mark question. So that's to 1 dp. Okay, so that's question 7. Let's move over to question 8. We've got metal rods are made from steel with density 8 grams per centimeters cubed. Each metal rod has a volume of 1,500 centimeters cubed. Okay, so we've been given the density. We've been given the volume. Just remember, density equals mass divided by volume. As you can see here, there's mass divided by volume in the units. Okay. The maximum mass of metal rods that can be put on the trolley is 300 kg. Work out the greatest number of metal rods that can be put on the trolley. So we need to work out the mass. So rearranging this equation here, mass equals density times volume. I've just put volume up to the top. And I know the density is 8 grams per centimeters cubed. And the volume is 1,500. So there's no conversions needed because the units are fine. So putting that in the calculator, I get 12,000 grams. So remember density, this equation gives us grams, you can see it here. But the trolley is taking measurements in kg. So I need to change this mass to kg. So remember 1 kg is 1,000 grams. So I'm just going to divide this by 1,000. And I get 12 kg. So this means that one metal rod is 12 kg. So it says metal rods, each metal rod has a volume of this, so 1 metal rod. So this is the value of 1 metal rod. So what I could do is, if I know 300 kg can be put on a trolley, I could do 300 divided by 12 to figure out how many metal rods I can fit on that trolley. And the answer to that is 25 rods. So this is basically how much rods can be put on a trolley. Just worked it out. Okay, so that's question 8. Let's move over to question 9. Okay, 3x to the power of minus 1. I'm just going to rewrite this out again. 3x to the minus 1 times 4x minus x cubed can be written in that form. Find the values of a, b, and n. So basically write it in this form here. So there's a few different ways you could do this. I'm going to change this one to 3 over x because x to the minus 1 is 1 over x times by 4x minus x cubed. Expanding this, 4 times 3 is 12. We've got x on top and then x on bottom. Timesing the next one out, 3 times minus x cubed is minus 3x cubed over x. Simplifying that, the x's cancel there. Here they cancel. That goes down to 2 because x cubed divided by x, we do 3 minus 1, which is 2. So we've got 12 minus 3x squared. And that's the same form as this here. So let's just explicitly state what is a, b, and n. Well, a is just 12. B is minus 3. Be careful to include that minus as well. Let me just get rid of that circle. So it's minus 3 for B. And then n is just the power, which is just 2. So that's a good 2 marker, just an indices rules one. Okay, solve 14 minus x over 3 equals 3x. So I'm going to times this 3 up first. So I get 14 minus x equals 3x times 3, which is 9x. Now I need to get all the x's on one side. So I'm going to bring this minus x over to the right-hand side so I keep my x's positive. Makes it easier to work with. So 9x plus x is 10x. Now to get x by itself, I need to divide by 10. So 14 divided by 10, which is just 1.4. That's a nice, easy 2 marker. Okay, so Freya and Ria each do an exam. So we've got another probability question. I think we had 2 probability questions in the first paper as well. So the probability that Freya will pass the exam is 0.8, which I can see here. So there's a tree diagram. There's Freya's here, and then Ria's is here. Okay. So I could see 0.8 here. The probability Ria will pass is 0.85, which is on that tree. Complete the probability tree diagram. And remember, each of these have to add up to 1. So doing that, 0.8, 1 minus 0.8 is 0.2. So that's 0.2. So the probability Freya will fail is 0.2. For Ria, if she passes, it's 0.85. So 1 minus 0.85 is 0.15. And we just need to repeat the same thing here. Because if Freya fails, and then that doesn't affect Ria passing or failing. So therefore, the probabilities stay exactly the same. Okay, so that's the tree. That'll help us with the next question. Work out the probability that only one of Freya or Ria will pass the exam. So only one of them will pass the exam. So we could have the probability that Freya passes. So I'm just going to call it FP. So we could have the probability that Freya passes, but because we only want one of them to pass, that means Ria would have to fail. So I could say probability that Freya passes, but Ria fails. But I could also have the probability that Freya fails, so FF. So she could fail, but I need Ria to pass in that case because at least one of them needs to pass. So then it could be Ria passes. So these are 2 probabilities, so we add them together. So how do I work out each of these probabilities here? Remember, we just times across the tree diagram. So the probability that Freya will pass is 0.8 times Ria failing is 0.15 plus the probability that Freya fails is 0.2 times the probability that Ria will pass is 0.85. Okay, putting that in the calculator, we get just put my equals here. 0.12 plus 0.17, and that gives us 0.29. So I was if you end up getting a number more than 1, you know you've definitely gone wrong, and that seems like a sensible number. 0.29, a chance of 29% that either Freya will pass or Ria will pass. So at least one of them will pass the exam. Okay, that's question 11. Let's move on to question 12. Well, the table gives some information about the ages in years of 32 actors. So in total, we've got 32 actors. What have they given us? They've given us the lowest and highest age. They've given us the lower quartile, upper quartile, and the median to draw a box plot. So the lowest age is 21. So 21 just lies around here. The highest age is 80. So I can put that like so, just over here. Okay. The lower quartile is 31. Where's 31? 31's approximately here. I'll do it like so. Obviously, you would use a ruler in the exam. Upper quartile is 42, so 42 reading of about there. That's the upper quartile. And we've got the median of 35, so 35 is just in the middle, like so. And then we just join them, obviously using a ruler, like so. So yeah, make sure you use a ruler for that. So nice, easy 3-marker, plotting all the information on. It says work out an estimate for the number of these actors with an age between 31 years and 42 years. Now 31 is the lower quartile and 42 is the upper quartile. So we've basically got the interquartile range, which is 50% of all of them, because the upper quartile is 75%, the lower quartile is 25%. So 75 minus 25% is 50. And 50, we're doing 50% of the total, which is 32 actors. So of 32, so half of 32 is just 16. So that's my answer. Okay, Mary says at least one of the actors is 35 years old because the median is 35. So you can see the median is 35. Is Mary correct? Give a reason for your answer. Well, to work out the median, we're basically finding the middle number. And because we've got 32 actors altogether, to find out the middle, we do 32 actors plus 1 divided by 2. So that's 33 divided by 2. So we're going to get a decimal answer. We get 33 divided by 2. That gives us the 16.5th number. So that means for us to find the median, we've had to go in between two numbers. So 2 actors' ages to get the answer of 35 for the median. So therefore, Mary is wrong for that reason. So just explain what I just said there, put it in some words. The fact that she's gone for the 16.5th number, which is in between two numbers, and in between them two numbers was 35. That does not mean that one of the actors is 35. So that's not definition of median. Okay, we've got expanding triple bracket one now for question 13. 2x plus 3 times x minus 1 times x plus 2. So that it can be written in this form, basically expanding it. And I'll just state what A, B, C, and D are, just to show the examiner I've done it. So we've got 2x plus 3 times x minus 1 times x plus 2. So I know some of you use grid method to do this. I'm just going to expand these two first. And then my answers, I'm going to then times by that is the method that I choose to do for this one. 2x times x is 2x squared. 2x times minus 1 is minus 2x. 3 times x is 3x. And then 3 times minus 1 is minus 3. So I've expanded these two brackets. And then I'm just going to write x plus 2 down. Let's simplify this. 2x squared minus 2x plus 3x is plus x minus 3 times x plus 2. Now what I'm going to do is I'm going to do 2x squared times both of these, and then I do x times both of them, and then I do minus 3 times both of them. Okay, so 2x squared times x is 2x cubed. 2x squared times 2 is 4x squared. Okay, so let's move on to the next one now. X times x is x squared. X times 2 is 2x. Then we've got minus 3 times x, which is minus 3x, and then minus 3 times 2, which is minus 6. So now let's just simplify this and collect like terms. So 2x cubed, there's no other x cubed, leave that as is. 4x squared as x squared is 5x squared. 2x minus 3x is minus x, and then we've got minus 6. Now let's just state we've expanded it. So a is what's in front of x cubed, which is 2. B is what's in front of x squared, which is 5. C is what's in front of x, which is a minus 1. And then D is just the final term, which is minus 6. So I think a lot of people forget about that minus that's there. But yeah, that's question 13 for 3 marks. Moving on to question 14. So there are 15 dogs in a dog show. One dog is awarded the first prize, and then a different dog is awarded the second prize. Okay, There are 12 cats in a cat show. One cat's awarded the first prize, and then a different cat is awarded the second prize. Work out how many different ways these 4 prizes can be awarded. So we're using the product rule for counting. So let's deal with the dogs first. We've got 15 dogs. Now, one dog is going to win the prize. So that one dog is out, and then there's 14 other dogs they could potentially win with. So we're doing 15 times 14. We get 210. Now for the cats, there's 12 cats in total. Because one cat is awarded the first prize, that one cat can be combined with all the other 11. So that gives us 132. But because we're working out the different ways these 4 prizes can be awarded, we need to then times these 2 by each other because it's for both shows. So it's 210 combinations times 132 combinations from the cats. That gives us 27,720 different ways that the 4 prizes can be awarded. So that's for 3 marks. Okay, question 15. Okay, so it says on a grid, show by shading the region that satisfies all these inequalities. So we've got 4 inequalities here. Okay, and label the region R. So we're gonna have to draw these 4 onto the graph, and then we'll start shading. I'm gonna deal with the easy ones first, which are these 2 here. So y is more than 1. We're basically drawing the graph y equals 1. So where is y equals 1? Well, here's y, the y-axis, over here. So remember your y lines are always horizontal lines that you're drawing. So y equals 1 is over here. Because there's no equal sign underneath that inequality, I'm just drawing as a dotted line. Please make sure you use a ruler for this. I'm just doing a rough sketch. So that's the line y is more than 1. Now, if y is more than 1, it will satisfy above this line. So just keep that in mind. So it's going to satisfy above that line. Let's do x is more than 2. So here's x equals 2 is a vertical line that way. Again, there's no equal sign underneath, so I'm just drawing a dotted line going down here. Because it's more than that, my region that's going to be satisfied is going to be on the right-hand side of that line. Okay, let's deal with these 2 more difficult ones now. I'll do this one first because it's already in the form y equals mx plus c. So I'm just sketching the line y equals 3x minus 2. So I need 2 points to plot, and then I can just join them together. So let's make x 0. So when x is 0, 3 times 0 is 0. And then we've got 0 minus 2, which is minus 2. So 0 minus 2. Sorry. Okay, that's fine. Let's find another one. Let's substitute when x is 1. 1 times 3 is 3. 3 minus 2 is just 1. So it's just 1, 1. So 1, 1 is here. So I can draw. It's a bit tricky to do this without having a ruler. Yeah, it'd be a lot easier if I had a ruler to be able to do this. So I'm not second guessing where the lines are going to be. What I'm going to do is I'm going to draw a straight line, but make sure you keep it dotted is what I'm going to say. So I think I can draw a straight line on here. Okay, so I'm going to draw it as a solid straight line, but this does have to be dotted. So let me just extend that. It has to go through minus 2. Yep, so just make sure that line is dotted. So this line here is the line, I'm going to write it down here, y is less than 3x minus 2. Now, if it's less than, it's going to be below this line. So I'm just going to do an arrow here just so I know it's below this entire line, the region R. Okay, so we've done that one. Let's deal with this one here. X plus y is less than 5. So I need to rearrange the equation to make y the subject. So I can say y is less than minus x plus 5. So I'll just minus x to the other side. So again, let's make x equals 0. When x is 0, minus So I'll write here y equals minus x plus 5. So when x is 0, minus 0 plus 5 is 5. So I've got 0, 5 here. Let's make y 0, see what happens here. So if I make y 0, it doesn't matter what coordinates you substitute in, you just need 2 points to be able to draw the line. We've got minus x plus 5. So I need to make x positive, so I'm going to bring it to that side. So I get x equals 5. So we've got 5, 0. Again, I'm going to draw a solid line, but just make sure you draw it dotted. Okay, so that's the line there. And because it's less than that, it satisfies underneath, so going downwards. So looking at all these lines together, if it's above the y equals 1 line, it's above here. It's to the right of this x is more than 2 line. It's below this line here, so this is our region R here. I'm going to just shade it in blue. So that's our region R. Let's write that down. Okay. So that's how you do that question. Just to reiterate, these two solid lines have to be dashed because there's no equal sign underneath these ones on any of them. So yeah, they all have to be dotted. Okay, Ron says I can remove one of the 4 inequalities from the grid so that region R will not change. Ron is correct. Which one inequality can be removed so that region R will not change? Well, you can see region R is bound between this line, this one, and this one. So the one that's not affecting it is this one here. And we know that that is y is less than or not equal to, y is less than 3x minus 2. So if you remove that inequality, it would not affect region R. So that's question 15. Let's move over to question 16. So 2 jars are mathematically similar, meaning that there's going to be a scale factor between them. Work out the height of the smallest jar, which we can see is h here. So you can see we've been given the volume. So I could work out the volume scale factor. So if I did 1,350 divided by 90, so the volumes divided by each other, that gives me 15, which is a volume scale factor. Now, just to reiterate, the scale factors for each length, area, and volume. So for length, I can say x, area x squared, volume x cubed. So that's your scale factor rules. Now, if we know the volume scale factor is 15, we can work out the length scale factor by cube rooting 15, because I'm getting from volume to length, so I need to cube root it. So that's my length scale factor. So to work out h, I just need to do 12 divided by the scale factor that I've just found for length. So 12 divided by the cube root of 15 gives me 4.8657, continues forever. It wants it to 1 decimal place, so that's 4. This 6 changes the 8 to a 9, so it's just 4.8. The units is centimeters, and that's h, what I've just found. So that's a good 4-mark question. Okay, moving on. The surface area of the smaller jar is a centimeter squared. The surface area of the larger jar is PA centimeter squared. Find the exact value of P. Now, if I've worked out the length scale factor is the cube root of 15, then that means the area scale factor is going to be the length scale factor squared. So I have to square to go down here. So it's always handy putting them rules to the side. So I need to square this. Now, you could see the difference between each of these is just a difference of P. So where P is the area scale factor. So because we want the exact value, I can't just put that in the calculator because it won't give me an exact value. So let's use our indices rule. Cube root, how can we write that? We can say 15 to the power of a third, because to the power of a third is a cube root, and we're squaring that. What do our indices rules tell us here? We just times them across, so 15 to the power of 2 over 3. And that's our answer. P is just 15 to the power of 2 over 3, because the difference between the surface area of the smaller jar to the larger jar is just by a difference of P, where P is a scale factor. That's a nice 1 mark question. That's question 16. Let's move over to question 17. So it says here is a sketch of part of a graph of y equals k to the x, where k is a positive constant. Okay, and it's given us 1 point on the graph here. So the graph passes through the point with coordinates -1, 1.5. So they've just given us 1 coordinate there. Find the value of k. Well, to find out k, if I substituted a known value of y and x in, I can find k. So I know y, I'm going to use the coordinate -1, 1.5, and I'm going to substitute it in to y equals k to the x. So y is 1.5 equals k, which is what we're finding, to the power of x, which is -1. I can change that to 1.5 equals 1 over k, because k to the -1, indices rules, it's 1 over. Now, to bring k up, I'm just going to times, so 1.5 times k equals 1. I want to get k by itself. I need to get rid of that 1.5, so it's 1.5 times k, so I'm dividing it, which is the opposite. So 1 divided by 1.5 gives me 2/3. That's my answer for k. Okay, question 18. At the start of year n, the population of the day in a park is dn. At the start of the following year, the population of the day is dn plus 1. So it's an iterations question. And the reason why I know that is because of that n and n plus 1. So that's the big clue. So they've given us an equation where k is a constant, so we don't know what k is. Okay. It says at the start of 2019, the population of the day was 2,000. And at the start of 2020, the population of the day was 2,400. Show that at the start of 2022, the population of the day was greater than 3,000. Now, if I'm working out the population of 2022, I need to know the population of 2021, which they've not given us, so keep that in mind. And we also do not know the value of k in this equation, which is what we also need to find, and we're going to use this fact here. So let's look at 2020. We can say in 2020, the day population, they've told us, is 2,400. And we know that equals k times the population of the year before, because it's dn. So the population in 2019 is 2,000. So just to reiterate, in 2020, we know the population of the day was 2,400, which is why I wrote that. For dn plus 1, we need the previous value of 2019, which is 2,000. And I'm doing this because I want to work out what k is. So to find k, I'm just going to divide by 2,000. So 2,400 divided by 2,000. That just gives me 1.2. So I've got a new equation now. I've got dn plus 1 equals 1.2 times d to the n. Let's work it out now for 2021, now that we know k. So for 2021, I'm just doing k, which we've just found is 1.2, times the previous year, which is 2020, which I know is 2,400. That gives me 2,880. We don't want it for 2021, we want it for 2022. So for 2022, I'm doing k, which is 1.2 times the previous year, which I've just worked out is 2,880, and that gives me 3,456. And we're showing that the population of the day was greater than 3,000. Well, 3,456 is greater than 3,000, so we've just shown it. Okay, so a bit of a different 3-mark question. It's not the usual iterations one that you're seeing. It's kind of similar, but not really. They've put it in equation format. Let's move over to question 19. Okay, so A, B, C, D, E, F, G, H, the cuboid. So you can just see each of the vertices are all there. They've slotted some triangles into there as well. It's given us some angles which are labeled in. So GEF 52 is here, BHG 27 is here. EF is 15, so EF, that's just 15. This whole length here. Okay, let me put that a bit neater. Work out the size of angle GEB. Let me do that in red. GEB, where is that? GE B. Okay, so this one here. We want to work out the angle of this here. So I'm going to call that X here. That's what we want to try and find out. So I can see there's a triangle slotted into there. I'm going to pull that triangle out. Now, when you're pulling triangles out, it's a good, with 3D trigonometry especially, write down the coordinates that they are. So I'm pulling out this slotted triangle where this is B, that's G, and that's E, just so you can visualize when you're using other triangles how it relates to your original one. So we are trying to find this. This is X, which that's what we want to find. The question said work out GEB. What else do we know? We don't know anything else. We know it's a right angle triangle. We don't know any of the lengths. We don't know the bottom. We don't know the hypotenuse. We don't know this side either. So we'll leave that as is. This is a triangle we need to keep referring back to because this is what contains X. So let's find another triangle we could use. I can see one here. So this BGH here. Maybe I could use that one. Let's try that first. So I'm going to draw it out. So BGSH this time. So the bottom, if I know this is 15 here, then that's going to be 15 there. So I can put that here. And I know this angle is 27. I don't know anything else. Now, what can I find from this triangle that will help me with this triangle? Well, this side here. If I find BG, I can put it there. So let's find outside BG. We can't use Pythagoras because we've only got one length. So we're going to be using SOHCAHTOA. So let's label the triangle. This is hypotenuse because it's opposite the right angle. This is our adjacent because it's next to the 27, and this is opposite. Now, because we're finding BG, I'm going to be using O, and I've already got A, so I'm going to be using tan. So that means tan of our angle 27 equals opposite, which is length BG, over adjacent, which is 15. So rearranging this, BG just equals 15 times tan 27, and that gives me 7.64288. You want to give this to a few decimal places because you don't want rounding errors early. So we found BG, so I can put this here. 7.642, I'll just say 29. I'll round it to 1 up, basically. Okay, so we found length BG, but that's still not enough on this triangle here to find X. I still need another length, maybe another angle. I need something else. So let's pull out another triangle from up here. What could we do? I can see a triangle on the bottom here. This here, GEF. So let's pull that out. Okay, so G, F here, and then E here. I know this is 15. I see that at the bottom. I know this is 52. Okay, I don't really know anything else. Now, let's look at this bottom triangle compared to this triangle here. Well, what's the same? Well, we've got GE here and we've got GE there. So I could work out GE on the bottom triangle, which will give me it on the top. So GE is the important length for me, just like BG was the important length there. Okay, so I can't use Pythagoras because I've only got one length, so it'll be SOHCAHTOA again. Okay, so what's the length we care about? We care about GE. Let's label the triangle first. So this is our hypotenuse because it's opposite the right angle. Here's adjacent, that's opposite. We want to find H, GE, and we've got A, so we're going to be using it with A and H, that's cos. So cos of the angle 52 equals adjacent, which is 15, over the hypotenuse, which we don't know. So GE, that's what we're finding. So making GE the subject, that's 15 divided by cos 52. I'll just swap these two over. So GE, we get 24.364 continues forever. So we found GE, I can put it on the top, 24.364. Okay, so now looking at this triangle, let me bring this triangle to the bottom. Put this one up to the top. By the way, there are many different ways you could have done this question. This is just one of the ways. I'll just bring this a bit up so we've got space. Okay, so now we can work out x because we've got two lengths now. So let's keep this separate. Okay, so again, because we're finding an angle, we're finding angle x, we're using SOHCAHTOA. Let's label the triangle. So hypotenuse, this is adjacent to x and that's opposite to x. We don't have hypotenuse, we've got these two. So we'll be using something with A and O, that's this one here. So tan of our angle x, which is what we're finding, equals opposite 7.6429 divided by adjacent, which is 24.364. So therefore, to find x, angle x, I'm going to just do, I'll write here, x equals tan to the -1 of this 6429 over 24.364. Putting that in the calculator, I get 17.416. We want to round that to the nearest degree. So this 4 keeps that 7 as is, so we get 17 degrees to the nearest degree. That seems like a sensible answer for BEG, little x. 17 seems like a reasonable answer. Okay, so that's question 19 for 4 marks. That's 3D trigonometry. Let's move over to question 20. Okay, so we've got the a diagram here. It says A is a 0.08, so this is 0.8, so that means I know it crosses at 8. And it says B is a 0.160, so here's B, so that's 16, because 16 in the x, 0 up. Okay. Point D divides the line segment AB in the ratio 1 to 3. So this, there's D. So that is 1 to 3 as a ratio. So if it's 1 to 3 as a ratio, that means I'm going to just evaluate this. There's 4 parts altogether. So it means A to D is 1/4 of the whole of AB. And I can say DB is 3/4 of the whole way. So that's how the ratios split, basically. Line L passes through D, which I can see here. Here's line L. It says the gradient of L is √3. Okay, that's fine. Let me just label the diagram. So the gradient of this is √3. L passes through the point with coordinates -2f. So -2 is like back here, f. So this line down here basically is going to cross -2f. So it's somewhere down there on L. And it says show that f is less than -4. Now the only way we can find out what f is, so the y, is to find out what's the equation of this line. We need to figure out what is y equals mx plus c of this line, and then we can substitute in this -2, and then we'll find out what f is, and we can check is it less than -4. Okay, so what's the equation of this line? Well, m is the gradient, c is y-intercept, so I can say y equals √3 x plus c. But I can't find c. I don't know where it crosses the y-axis, and I don't have a point on this line. But what I could do is I could find out point D here. because D lies on line L, and I can substitute that into here to find out C, and I've got the equation of the line. So that's what I need to do. A bit tricky to figure out what we needed to do there, but we need to find out coordinates of D. How can we do that? I know that A, now let's look at this line here, so this opposite line. We're going to use that to work out what is coordinates D, to then be able to substitute into here. So A is 0, 8, B is 16, 0. So to get from A to B, in the X direction, I'm going to do 16 minus 0. So 16 minus 0, so the X coordinates minusing each other, so I just get 16. And in the Y direction, so in the same way, I'm going to do 0 minus 8. So I get minus 8. Okay, so that's how much away A and B are from each other in the X and the Y direction. Now, what we need to figure out, we know that D is a quarter of the way from A. We've evaluated that from the ratio. So if we find out a quarter of 16, which is in the Y direction, so a quarter of 16 is just 4. And if I find out a quarter of the Y direction, which is minus 8, that's just minus 2. So that's how much coordinates it is to get, like in the X direction and the Y direction, to point D. But we're not done there. We need to add these to our starting position. Our starting position is A, which is 0, 8. So I need to do, for the X part, I need to do 0, add 4. And for the Y, I need to do 8 minus, add minus 2, which is just minus 2. So 0 add 4 is just 4, 8 minus 2 is 6. So therefore, our coordinates of D is 4, 6. This is the coordinates of D. So now that we've found the coordinates of D, we can substitute it into our y equals mx plus c line to find C. So I'm going to do this in a different color. We said y equals root 3x plus c. Substituting this in, I get 6 equals root 3 times x, which is 4, plus c. So 6 equals 4 root 3 plus c. So c just equals, I'm going to do 6 minus 4 root 3. I'll just leave it accurate. It's fine. And then I can substitute this c back into the equation. So y equals root 3x plus what we've just found, 6 minus 4 root 3. So we've got the equation of line L now. We've just found the equation of line L. We want to find the coordinates of F. So I'm going to substitute minus 2 in. So substitute minus 2F. So the y is F equals root 3 times x, which is minus 2, plus 6 minus 4 root 3. Putting that all in the calculator, we get F equals minus 4.392. Now the question says show that F is less than minus 4, and it is. We've just shown that F is minus 4.392, which is less than minus 4, so we've just proved it. So that was a tricky 5-mark question, for sure. That's question 20. Moving on to question 21. This was a lot longer than paper 1. Paper 1 was only 17 questions, but more bigger ones. There's much more questions here. So we've got a quadratic inequality, but they've done quite good by already factorizing it for us. That's the reason why it's only 2 marks. Remember, with quadratic inequalities, we always have to draw the graph. I know this is a U-shaped graph because 3x times 5x is 15x squared, so it's a positive x squared, so it's a U-shaped graph. I just need to find where does it cross the x axes, so I can figure out where the inequality is. So all I'm doing is making 3x minus 1 equal to 0 and 5x plus 2 equal to 0, and I'm solving each of these equations. So 3x equals 1, x equals 1 over 3. Let's do the second one. 5x equals minus 2, so x equals minus 2 over 5. So they're my 2 coordinates. I can say minus 2 over 5 is over here, and it's just a sketch, so that's minus 2 over 5. That's a third. we want to solve it when it's less than 0. Remember, less than 0 is below the x-axis. So it's just these values here. How do I represent that as an inequality? Well, x is between a third and minus 2/5, because x is all these values in between here. So that's my answer for question 21. Let's move over to 22. The equation of a circle A is x squared plus y squared equals 25. So that means our radius for this one is 5. And remember, our center is 0, 0. So if I was to sketch circle A, it would look something like this. So that would be 5, that would be 5, that would be minus 5, and that would be minus 5. Center would be 0, 0. I've drawn that a bit weird. It should have been a bit downer, but it's fine. It says circle A is translated by the vector 0, minus 2. What does this do? It's moving it 2 down. So it's not moving in the x direction. It's just moving this circle A fully down to give circle B. Sketch circle B and show the coordinates of the center and where it meets y-axis. Okay, so we're shifting this whole circle down. So the minus 5 and 5 in the x direction won't matter. So it'll still be there. If I'm shifting downwards, this 5 here has now become 3. I'm just going to draw this on. So that's now become 3 because it shifted 2 down. And then our bottom one here, the minus 5, has shifted 2 down, so it's minus 7 now. These ones remain the same. That's 5, that's minus 5. Our center is no longer 0, 0. It's moved down 3. So not 3, sorry, 2. So it's now, the center would be approximately there, so minus 2 down. So as you can see, the whole circle has been shifted down by 2. It's not changed in the x direction. So that's circle B for 3 marks. Let's do question 23, and this is the last question. Okay, so it says ABCD is a quadrilateral, four-sided shape, which I can see. Find the size of angle ABC. So ABC is this one here. I'm just going to put it in red. This is what I need to find here. Now, what I will have to do is I'll have to split this into 2 triangles. And the way I'm going to split it is this way here. So if I'm splitting the triangles like that, and I'm finding out the angle ABC, I need to find out this angle and this angle. So I'm going to call the top one X and then Y, and then angle ABC is just going to be X plus Y. So I'll find X and Y and then I'll add them together. So looking at these 2 triangles, I'm going to call this triangle 1 and triangle 2. Let's look at triangle 1. Okay. Let me just sketch it out, makes it a bit easier to work with. Now, notice that both of these are non-right angle triangles, so I'm going to be using sine rule and cosine rule. So I know the top here is 1, 2, 5. It's probably worth writing A, B, D. I know that this is 6 centimeters. What else do I know? I know I'm trying to find X. That's what I'm trying to find here. And that's it. We don't know anything else about that. Let's draw triangle 2 here. So it looks somewhat like this. So 60, we've got a 12 here, we've got a 9 here, and that's Y. So that's what we need to find in each triangle. Okay, so the triangle 1, I've not really got enough information to be able to use cosine rule or sine rule to find X. I need another length. So I've got more information on triangle 2, so I'm going to work with triangle 2 first. Now, what I should have really done is that's D, B, C. Now notice how I've got DB here. This length and this length is the same. So if I worked out the length on triangle 2 of DB, I can use that for triangle 1. So let's work out the length of DB. Now remember, there are loads of different ways to do this question, so there's just one of the many ways. So I'm going to work out the length of DB. How can I work out the length of DB? Well, I've got 2 lengths and I've got an angle. So I could use a cosine rule. What does cosine rule say? Cosine rule says a squared equals b squared plus c squared minus 2bc cos a. You get given that. Let's label the triangle. We always label the angle first, so that's angle A. Okay, so that would be side A. And then therefore these would be B and C. It doesn't matter which one's which. Substituting everything in, I've got A squared equals B squared, so 12 squared plus C squared minus 2 times B times C cos of 60. So putting that all in the calculator, I get A squared equals 117. So therefore A just equals the square root of 117. I'm just going to keep it accurate. So I've worked out this as root 117 like that. So I can put this here as well now. Okay, so I've got the length now. So I could use the sine rule to work out x here. So what does the sine rule say? So sine of angle x. Okay, sine of x, which is opposite 6 here. So sine rule is always the angle's opposite thingy. And then I've got sine of 125 over the length, which is root 117. So sine x equals, I can times this side by 6. So sine 125 over root 117 times 6. So x just equals the inverse sine of whatever answer you get here. So I'll just say sine x equals 0.4543, putting that in the calculator. X equals sine to the minus 1 of 0.4543. So x just equals 27.0253. So I've worked out x, this one here. I got 27.0253. So I just need to work out y. Now let's go back to triangle 2. How could I work out y? I could use a sine rule as well. So y is opposite 9 and I've got 60. Yep, so let's use the sine rule to find angle y. So sine of y over 9 equals sine of 60 over root 117. So sine y equals sine 60 over root 117 times 9. That gives me 339. Putting in the calculator, I got this. So y equals sine to the minus 1 of this answer. And I get 46.102. So this is 46.102. So to find angle ABC, I'm just going to do the answer up here. I'm just doing x plus y. So 27.0253. Add 46.102, we get 73.127. We want it to the nearest degree. Rounding that, we get 73 degrees. And that's our final answer for that one. So there was different ways to do that question. That is one of the ways to do it. So I hope you found that helpful. And I'll see you on another one. Okay, bye.